Good afternoon, children. Today I'm going to deliver my fourth online lecture. Today's topic is the basic concept of remote sensing. One of my students of third year, Smita, requested me to discuss this topic. So let's start. In 1859, Gaspard Tournacon took an oblique photograph of a small village near Paris from a balloon. With this picture, the era of Earth observation and remote sensing had started. Remote sensing is a process of Earth observation. This is a very sophisticated technique which now allows scientists to understand the Earth in ways we never before dreamed. From 1960 onwards, since the beginning of space flight, an ever-growing body of information is being gathered using a space-based remote sensing. Geography, agriculture, meteorology, oceanography, ecology, cartography, botany, geomorphology, and geology are just a few of the disciplines which have been transformed a lot by this technology. A definition of remote sensing usable in all places by all persons for all occasions seems not to exist. The term remote sensing is the combination of two words, remote and sensing. The dictionary meaning of the term remote is located in afar or distant. On the other hand, sensing means perceived by a sense or senses or to detect. The coining of the term remote sensing goes back to a white paper prepared in the early 1960s by the staff of the Geography Branch, Office of Naval Resource, for presentation to the Committee on Geography. The term remote sensing, promoted throughout a series of symposia sponsored by ONR at the University of Michigan, gained wide acceptance. Remote sensing is defined as the science and art of obtaining information about an object, area, or phenomenon through the analysis of data acquired by sensors that is not in direct contact with the target of investigation. Such a definition is short, simple, general, and memorable, but unfortunately not wholly adequate. While defining remote sensing, following points should be taken into consideration. Number 1. Remote sensing is gathering information about an object without touching it. Number 2. Remote sensing is a method of collecting information from a distance by instruments carried typically on aircraft or spacecraft. Number 3. Remote sensing is a non-contact recording of information from the electromagnetic spectrum by means of mechanical, photographic, numeric, or visual sensors located on mobile platforms. Remote sensing enables us to acquire information about a phenomenon, object, or surface while at a distance from it. Undoubtedly, a recording of data from a distance by means of instrumented sensor and their manipulation by data processing equipment employing complex mathematically and statistically based software algorithms is an activity that easily can be subsumed under the rubric of science. But photo interpretation requires considerable experience along with thorough training and depth in educational theory before the data captured by the sensors can be placed in a meaningful context. Therefore, the aspect of remote sensing that definitely can be called an art. Because both aspects are present, the most accurate conclusion would seem to be that remote sensing is the science and art. These images say we the humans have been applying remote sensing knowingly or unknowingly in our day to day business through vision, hearing, and sense of smell. Now we will talk about the stages of remote sensing. There are 6 interdependent stages in the processes of remote sensing. Number 1, sources of energy. Number 2, interaction of EMR, electromagnetic radiation with atmosphere. Number 3, interaction of electromagnetic radiation with Earth's surface. Number 4, interaction of reflected electromagnetic radiation with sensor. Number 5, receiving of signals by ground stations. Number 6, application. The first point is source of energy. Undoubtedly, sun is the source of energy, and the sun is considered the source of abundant electromagnetic energy. It is continuously emitting electromagnetic radiation. Now the point is, what do we understand by EMR or electromagnetic radiation? Simply, electromagnetic radiation is a dynamic form of electric and magnetic energy that propagates as wave motion at a velocity of light. The parameters that characterize a wave motion are wavelength, distance between corresponding points of two consecutive waves. Look at this image. These two consecutive waves, the distance between two consecutive waves is indicated as wavelength. Next one is frequency, and the frequency is the number of occurrences of a repeating event per unit of time, and number 3 is velocity. Electromagnetic energy radiates in accordance with the basic wave theory. This theory describes the electromagnetic energy as traveling in a harmonic sinusoidal fashion at the velocity of light. Although many characteristics of electromagnetic energy are easily described by wave theory also. Another theory, known as particle theory, offers insight into how electromagnetic energy interacts with matter. It suggests that electromagnetic radiation is composed of many discrete units called photon or quanta. The electromagnetic spectrum is a continuum of electromagnetic waves arranged according to frequency and wavelength. The electromagnetic spectrum is divided into several bands. These definitions are generally informal and vague, and the bands may overlap. If we look at the image, we find that there are the electromagnetic spectrum is divided into several bands like gamma rays, X-rays, ultraviolet rays, visible band, infrared, then microwave and radio waves. The first one is gamma rays, the second one is X-rays, and the next one is ultraviolet region. It is ranging between 0.30 millimicron to 0.38 millimicron. The next one is visible spectrum. The first one is violet, 0.4 to 0.4 millimicron to 446 millimicron. The next one is blue, 0.446 millimicron to 0.5 millimicron. Next one is green, 0.5 millimicron to 0.578 millimicron. Then yellow, 0.578 millimicron to 0.592 millimicron. Next orange, 0.592 millimicron to 0.62 millimicron. And the last one is red, 0.62 millimicron to 0.7 millimicron. This is the light. This visible spectrum is actually the light which our eyes can detect. This is the only portion of the spectrum that can be associated with the common with the concept of color. Blue, green, and red are the three primary colors of the visible spectrum. They are defined as such because no single primary color can be created from the other two, but all the other colors can be formed by combining the three of the various proportion. The color of an object is defined by the color of the light it reflects. Wavelengths longer than the red portion is infrared spectrum ranging between 0.7 millimicron to 100 millimicron. Wavelengths longer than the red portion of a visible spectrum are designated as infrared spectrum. British astronomer William Herschel discovered this in 1800 AD. The infrared region can be divided into two categories based on their radiation properties. Reflected EMR, reflected infrared, ranging between 0.7 millimicron to 3.0 millimicron. It is used for remote sensing. The next one is thermal infrared, ranging between 3 millimicron to 35 millimicron, and this is the radiation emitted from the Earth's surface in the form of heat and used for remote sensing. The next one is microwave region, ranging between 1 millimeter to 1 meter. This is the longest wavelength used in remote sensing. The shortest wavelength in these ranges have properties similar to thermal infrared region. The main advantage of this spectrum is its ability to penetrate through clouds. Then last one is radio waves. The wavelength is longer than 1 meter. This is the longest portion of the spectrum, mostly used for commercial broadcast and meteorology. The second point is interaction of electromagnetic radiation with atmosphere. While the electromagnetic radiation travels from sun to the earth's surface, it interact with the earth's atmosphere. During this interaction, a few amounts of electromagnetic radiation gets scattered, transmitted, reflected due to the presence of dust particles, clouds, and some microscopic pollutants. A major part of electromagnetic radiation gets scattered when the atmosphere contains pollutant. So, what is the scattering? It is a process in which a ray of light traveling on its path, when strikes with any particle, it changes its direction of travel or it diverts its path. The scattering is of three types. Number one, Rayleigh scattering. This type of scattering occurs when the particles that are responsible for scattering are smaller than the wavelength. Rayleigh scattering is responsible for the blue color of the sky. Number two is mere scattering. This type of scattering occurs when the particles that are responsible for scattering are almost similar in size to the wavelength. Mainly the smoke, dust, and few microscopic particles in the lower atmosphere are responsible for the mere scattering. The last one is non-selective scattering. This type of scattering occurs when the size of the particles are much larger than the rays of light. An important point I want to discuss here, that is atmospheric window. This atmospheric window is very much important and plays a very important role in the interaction between electromagnetic radiation and atmosphere. The atmosphere selectively transmits energy of certain wavelengths. The spectral bands for which the atmosphere is relatively transparent are known as atmospheric windows. Atmospheric windows are present in visible 4 to 0.4 to 0.76 millimicron. Let's see, this is 0.4 to 0.76 millimicron, and the infrared region of the electromagnetic spectrum here, and in the visible part of the transmission is mainly affected by ozone absorption and by molecular scattering. Thus, atmosphere is transparent again beyond the wavelength 1 millimeter, the region used for microwave remote sensing. Now, the third point is interaction of electromagnetic radiation with the Earth's surface. As soon as the electromagnetic radiation crosses Earth's atmosphere, it interacts with the Earth's surface. The electromagnetic radiation undergo the following processes while interacting with the Earth's surface. Number one, reflection. It is a process in which incident light rays of one medium, when strikes a shining surface or another medium, changes its direction of path to its medium of origin. For example, when a light ray incidents strike a mirror surface, it gets reflected back. And the next one is refraction. It is a bending of incident light rays when passing through another medium, traveling from one medium of different density. In other words, when a light ray traveling from one medium passes through another medium of different density, results in bending of light rays. This phenomenon is known as refraction. For example, when we put a coin inside a bucket full of water, the coin seems to be raised. Next one is transmission. It is the passage of electromagnetic radiation through a material or a medium. The effectiveness of transmission of radiation depends on the reflecting capacity of the material. If a surface has high reflectance, the transmittance will be reduced and vice versa. And the last one is absorption. When a ray of light strikes on an opaque surface, it is taken up by the surface and neither reflection nor refraction of lights occur. It is known as absorption. Absorption occurs when the ray of light stops reflecting or refracting just after striking on the target surface. For example, when an incident ray of light falls on a rough surface, black colored body, the incident ray starts getting absorbed by the body without allowing it to reflect back. The behavior of electromagnetic radiation after interacting with the Earth's surface completely depend on the surface characteristics. Number 4. Interaction of reflected electromagnetic radiation with satellite. It is better to say sensors. The reflected electromagnetic radiation are detected by the sensors mounted on the satellites. Sensors are the device that receive the information and convert it as per the user's requirement. The resolution of receiving device like cameras or sensors play an important role in getting the information about the target, object or location. Now the point, what is a resolution? Resolution is the ability of a system to acquire information or identification and the characteristics of different objects usually close to each other. Resolution is of 4 types. Number 1, spatial resolution. Spatial resolution is a measure of the smallest object that can be resolved by a sensor. Temporal resolution. This can be defined as the amount of time needed to revisit and accurate data for the exact same location. Number 3, spectral resolution. A resolution related to wavelength refers to the ability of a satellite sensor to measure a specific wavelength of the electromagnetic spectrum. The finer the spectral resolution, the narrower the wavelength ranges for a particular channel or band. The last one is radiometric resolution. It describes the ability to discriminate very slight differences in energy. The finer the radiometric resolution of a sensor, the more sensitive it is to detecting a small differences in reflected or emitted energy. After the satellite receives the information, it transmits the radio signal to the ground stations. Number 5. Receiving of signals by the ground stations. After the ground stations receive the radio signals from the satellite, it converts the raw data into useful information, that is digital or analog formats. Later, the satellite images are processed and corrected as per the requirements. And the last one is application. The processed satellite image data obtained from the ground stations are applied in different fields for the welfare of human society. Thank you. Today this much, and in the next class we will discuss about the type of remote sensing and platforms, etc. Thank you.